Section 31 of the Science History of the Universe, Volume 2. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Science History of the Universe, Volume 2, edited by Francis Rolt-Wheeler, Geology. Chapter 15, Descriptive Mineralogy, Part 2. Nickel, though formerly a little used metal, has become of much wider application in recent years. It is extensively employed now to plate many articles of steel, as knives, scissors, skates, etc., because unlike the steel it does not tarnish or rust rapidly in the air. It is much used also when alloyed with copper for small coins, as the nickels or 5-cent pieces of this country, and similarly in Switzerland, Germany, and Belgium. Nickel steel has been found to be remarkably strong in withstanding the blow of a cannon ball. The white alloy called German silver contains copper, zinc, and nickel in about the proportions of 5 to 3 to 2. There are not, however, many minerals which contain nickel. One of these is the sulfide millerite, another is nickelite or nickel arsenide. Cobalt is a metal related to nickel and often associated in nature with it in its various compounds, though of much more limited occurrence. As a metal it is not used in the arts, but its salts, which are most brightly colored, have some applications. From the change in color that certain of them undergo on heating and on losing water depends their use as sympathetic ink. Cobalt glass, called smalt, has a beautiful blue ultramarine color, and ground up is used as pigment. Manganese is a metal which is closely allied to iron in physical characters and chemical relations. As obtained by the chemist, for it does not occur in nature, it is hard and brittle. Like iron, it forms numerous natural compounds, but they do not find many applications in the arts. Zinc is one of the most common and important of the metallic elements, but it is not certainly known to occur in the form of the metal in nature. It has a crystalline structure like metallic antimony, a white color and brilliant luster, soon however tarnishing. It is brittle at both low and high temperatures, but at 140 degrees centigrade it can be rolled into sheets. It is a most important metal in the arts. Iron in sheets and wire coated by zinc are protected from rusting, and are then said to be galvanized. A common use of the sheets is for roofing. Zinc is the negative metal in almost all forms of the chemical electric battery, that is, the metal at the expense of which the electric current is obtained. With copper it forms brass and related alloys. It is also one of the constituents in German silver. An alloy of zinc is used for making raised cuts in photo engraving. The white oxide is used for paint. Metallic zinc, as obtained from the furnace in ingots, is called spelter. Aluminium is one of the most remarkable of metals, because while it has great tenacity and is in a high degree sonorous and non-oxidizable in the air, it has a specific gravity of less than calcite, or only 2.5. In other words, it is only about 1/3 as dense as iron and 1/4 as dense as silver, which it somewhat resembles. Both as the pure metal, because of its low density, and in alloys, for example, with copper as aluminum bronze, because of their strength and other remarkable properties, it is highly useful. Corundum, oxide of aluminum, is, next to diamond, the hardest of minerals and one of great interest. Its clear blue varieties make the sapphire of jewelry, and the clear red the highly prized ruby, while the coarse and impure kinds, when pulverized, are emery, used for grinding. The luster, like that of most very hard minerals, is brilliant and adamantine, though rather dull in some massive kinds. The color is gray to brown or nearly black in many of the common varieties, called in part adamantine spar, bright blue in the variety called the sapphire, red in the ruby, purple in the oriental amethyst, yellow in the oriental topaz. Turquoise, the beautiful precious stone having the color of robin's egg blue, also bluish-green in less highly prized varieties, is a hydrated phosphate of aluminium containing also a little copper phosphate, which is probably the source of the color. It occurs only in compact massive forms, filling seams and cavities in a volcanic rock. Calcium, whose oxide, CaO, is the familiar substance called lime, is a white metal somewhat resembling silver or tin. Its compounds are numerous and important, and it is indeed one of the most widely distributed of all the elements. Fluorite or fluorspar, calcium fluoride, is one of the most beautiful of minerals, occurring in cubic crystals and groups of crystals, sometimes very large and of a great variety of colors, from colorless to green, yellow, brown, red, and purple. The crystals are usually transparent and sometimes show on or near the surface a bright bluish color, quite different from that observed when they are looked directly through. The blue light extends within the crystal if it is placed in the direct sunlight. This phenomenon is called fluorescence, and having been first observed with fluorite, was named accordingly from it. Calcite, next to quartz, is the most common of mineral species, remarkable for its variety of form both among the crystallized and uncrystallized varieties. It crystallizes in rhombohedrons and scalenohedrons of great variety and complexity of form, also in hexagonal prisms. A clear cleavage mass of high-grade calcite, such as that brought from Iceland, is called Iceland spar and is useful for optical prisms. This is because of its remarkable double refraction, or power of dividing a ray of light passing through it into two separate rays, so that a line seen through it appears double. Besides the crystallized kinds, there are those which have a granular structure, as statuary marble, and which sparkle in the light because of the multitude of cleavage faces. Other kinds are fibrous with a silky luster, like satin spar, also close and compact as an ordinary marble, and then of great variety of color, red, yellow, blue, black, and largely used for ornamental purposes. Some of these kinds of marble still contain shells, which come out distinctly when polished. Gypsum occurs in monoclinic crystals. Twin crystals are also common. Gypsum also occurs in fibrous forms called, like the similar variety of calcite, satin spar. It is easily distinguished from calcite because so much softer. The luster is pearly on the face of perfect cleavage, otherwise subvitreous. It is also silky in some fibrous forms, and in earthy kinds dull. When gypsum is heated and the water of crystallization driven off, gypsum becomes the anhydrous sulfate. This is done on a large scale and called plaster of Paris, which is extensively employed for making plaster casts, for the hard finish for walls, and for other uses. Gypsum is also largely used when ground up for improving soils. The variety alabaster is soft and easily cut into vases and other ornamental objects. Magnesium is the metal which is present in the oxide MgO called magnesia. It is a white metal resembling calcium and closely related to it chemically. In the form of a thin strip or ribbon, it burns readily in the air, yielding a very brilliant white light, which is often used as a source of illumination in photography. Barium is a metal only known in the laboratory, where it can be obtained from some of its compounds. It is a heavy metal, and takes its name from this fact from the Greek word for heavy, barush. All its salts have also high density. Strontium is the metal which is present in the various salts characterized by the beautiful red color which they give to the flame. The nitrate is thus used in fireworks and red fire. The hydrate is used for preparing and refining beet sugar and in extracting crystallized sugar from molasses. The metals sodium and potassium, though obtained with some difficulty, are interesting to the chemist because they combine so eagerly with oxygen. For this reason they can be preserved only in some non-oxidizable medium, as oil, and a fragment of potassium placed in water takes fire and burns, uniting with the oxygen and liberating hydrogen. Sodium also decomposes water. Halite or rock salt, sodium chloride, is one of the few important minerals which is readily soluble in water and hence gives a decided taste. This taste is familiar to everyone, for halite is simply the natural form of table salt. It crystallizes in fine, clear, cubic crystals with perfect cubic cleavage. It is also found in granular cleavable masses. It has a vitreous luster and is colorless when perfectly pure, but from white it passes through various shades of red and yellow. Occasional patches of a deep blue are seen in the clear crystals. Borax, the sodium borate which is so familiar to the housekeeper, also occurs in nature, and on so large a scale in certain limited regions as to be extensively mined. It is found in monoclinic crystals, often of large size. They are clear at first, but lose water on exposure and become white and opaque. Borax finds many uses in the arts, as in making glass and soap, in soldering, and in medicine. Silicon is, next to oxygen, the most widely distributed of the chemical elements. In fact, it is estimated to make up about 1/4 of the Earth's crust. The element itself is known only to the chemist, who obtains it with some difficulty from its compounds. One form is that of reddish crystals, resembling those of the diamond and almost as hard. The common compound of silicon in nature is the oxide, SiO2, called usually simply silica. The well-known mineral quartz has this composition. Opal is another kind of silica, amorphous and containing some water. Quartz, the oxide of silicon, is the commonest of minerals, and in some of its varieties one of the most beautiful. It makes up most of the sand of the seashore. It occurs as a rock in the forms of sandstone and quartzite, and is a prominent part of many other important rocks, as granite and gneiss. It is a mineral which can be usually recognized by its form when crystallized, also by its hardness, conchoidal fracture, its glassy luster and infusibility. The color varies widely. Crystals are usually colorless or nearly so, but also yellow and brown to nearly black. There are also pink, green, and red kinds. The massive forms vary still more, and the color is often in bands or clouds. Quartz appears under a great number of varieties, differing particularly in color and structure, and as many have been long used for ornamental purposes, they have received a number of distinct names. Rock crystal, the clear, colorless variety, when quite free from flaws, is used for spectacle glasses, and the Japanese make crystal spheres of rock crystal. Smoky quartz, having a smoky brown color, sometimes very dark. It is cut into ornaments, and in Scotland it is called cairngormstone. Amethyst, a fine purple kind, also used for ornaments. A yellow variety of quartz crystal is called false topaz. Cat's eye may be mentioned, giving when polished a peculiar effect of opalescence, due to fibers of asbestos, which sometimes resembles the reflection from the eye of a cat. The same name is given to other stones having like effects. The highly prized cat's eye of jewelry is a variety of crystal beryl. Chalcedony is a kind having a waxy luster, either transparent or translucent, and varying in color from white to gray, blue, brown, and other shades. Agate is a variegated chalcedony, commonly with the colors arranged in delicate parallel bands, straight, curved, or zigzag. Onyx is, like much agate, made up of layers of different colors, usually white and black or white and brown, but the banding is straight, and the layers are in even planes. The stones may hence be used for cameos, the head being cut from one layer and the background formed by the other. Jasper is an impure opaque colored quartz, often red, colored by red iron sesquioxide, also brown or ochre yellow and dark green. Sometimes the red and green colors are shown in the same specimen, arranged in bands as in ribbon jasper. And flint, which is nearly opaque and has a dull color, usually gray, smoky brown, and brownish black. It breaks with a deeply conchoidal fracture and a sharp cutting edge, and is hence easily chipped, as by the Indians, into arrowheads or hatchets. Opal is a form of silica containing a few % of water. It does not occur in crystals, but in massive and amorphous forms only. These often show a peculiar effect called opalescence, like that of water containing a few drops of milk, and some varieties show a beautiful play of color. The color varies from white to yellow, red, brown, green, gray, and black. It is sometimes transparent, but more commonly only translucent. The most beautiful variety of opal is much admired because of the delicate play of colors, due to the optical effect of internal reflections. The colors are often seen on a white, also on a red ground. One kind of precious opal with a bright red flash of light is called the fire opal, and another kind is the harlequin opal. A beautiful opal found in Queensland shows an iridescent blue, sometimes like the effect of a peacock's wing. Infusorial earth is a kind of opal silica consisting of the microscopic shells of the minute vegetable organisms called diatoms, and as found in beds, sometimes of great extent, is properly ranked as a mineral and a variety of opal. Electrosilicon is the trade name of one kind much used for polishing silver. The silicious shells are so fine that they do not scratch the surface. A layer of pure white infusorial earth is often found under a peat bed. It would not be easy to estimate the enormous number of the diatom shells which would be required to make up a cubic inch of it. Beryl is one of those species which are almost always in distinct crystals and usually in forms easy to recognize. It is also interesting because some varieties are used as a gem. The hardness of beryl is 7.5, or a little above that of quartz, and on this account and because of the beautiful color it sometimes has its rank as one of the precious stones. The luster is vitreous or glassy. In this respect also it resembles quartz, and the color is usually some shade of green, bluish green in common beryl, clear mountain green in the variety called aquamarine, and a deep emerald green in the highly prized variety emerald. There are also light or dark yellow kinds, sometimes having a rich golden color and occasionally white, and still more rare, pink kinds. Garnet is another species which, like beryl, is almost always in distinct crystals, and as these crystals are commonly isolated and scattered through the rock, it is not difficult to recognize them. There are, however, massive kinds needing some skill for their identification. These are occasionally used in the same way as emery, though much less hard. The luster is vitreous, and the color, while most commonly red, varies also from the colorless kinds to those which are yellow, brown, black, and green. The micas are characterized before all by their very perfect cleavage, in consequence of which they admit of being split into leaves much thinner than a sheet of paper. In fact, it is difficult to set any limit to the extent to which this process may be carried. These leaves or sheets are usually very elastic and spring back with force when bent. The micas are silicates of alumina with potash, rarely soda or lithia, also magnesia, iron, and some other elements. Chrysolite, or olivine, is a silicate of magnesia and iron having a vitreous luster and bright yellowish-green color. The luster is vitreous, and the color, besides that mentioned, may be yellow to olive green and brown. Chrysolite, golden stone, from the Greek chrysos, gold, and lithos, stone, is an old term in the mineralogy of former times given to a number of yellow minerals used as gems, thus to beryl, topaz, chrysoberyl, and zircon. Tourmaline is one of the most attractive minerals among the silicates. Its varieties show a greater range of color than any other species, not even excepting fluorite, and some of the clear pink and green kinds make beautiful gems. It is also always found in prismatic crystals, bounded often by 3 sides, sometimes by 6, also by 9, and not infrequently rounded so that there are no distinct faces to be distinguished at all. Topaz is another gem silicate, beautiful in its fine crystals and in its brilliancy of luster and color. It occurs in prismatic crystals, terminated by rhombic pyramids, sometimes acute, sometimes obtuse. There are also coarse crystals and massive fibrous forms, but these last are not so common. The perfect basal cleavage of topaz is one of its most characteristic points. Hard as it is easily broken in a direction across the prism, and will yield thin plates with very smooth faces. The luster is vitreous, and the color varies from colorless to white, wine yellow, and blue. Pink topaz is sometimes found. Serpentine is a remarkable mineral because of the variety of massive forms it assumes, although it is not known to occur in crystals of its own. The crystals of serpentine which are found are what are called pseudomorphs, having been derived from some other species by chemical change. The most peculiar variety is the fine fibrous kind called chrysotile, not to be confounded with chrysolite. This usually occurs as thin seams in the massive mineral. Chrysotile may be separated into fibers, very flexible and as soft as the finest silk. This variety is popularly called asbestos, but there is another kind of asbestos of rather similar appearance, which is a variety of the mineral amphibole. These brief descriptions of the principal minerals may serve in some measure to clarify and determine the reader's knowledge of the metals he handles and the stones and rocks whereon he treads. But even so, there are fields illimitable of investigation. These might be pointed out in almost any of the minerals, but the question has been so excellently well worded by Ruskin with regard to marble that it may serve for all. Another singular point in the business to my mind," he says, is that these stones, which men have been cutting into slabs for thousands of years to ornament their principal buildings with, and which under the general name of marble have been the delight of the eyes, and the wealth of architecture among all civilized nations, are precisely those on which the signs and brands of these earth agonies have been chiefly struck, and there is not a purple vein nor flaming zone in them which is not the record of their ancient torture. What a boundless capacity for sleep and for serene stupidity there is in the human mind! Fancy reflective beings who cut and polish stones for 3,000 years for the sake of the pretty stains upon them, and educate themselves to an art at last, such as it is, of imitating these veins by dexterous painting, and never a curious soul of them all that while asks, what painted the rocks? Unquote. End of chapter 15. End of section 31.